All right, 8.2, where quadratic functions in the standard form where b equals 0. What does that mean? Well, here is the standard quadratic form, f of x, or y, remember those are interchangeable, equals ax squared plus bx plus c, where a, b, and c are numbers, any numbers. So when you go to do an actual problem, it will look something like 3x squared plus 2x plus 4. Like that. See, A becomes a number, B becomes a number, C becomes a number. So these are just stand-ins for numbers when we're talking about the universal form that all of them will follow. Now, the special circumstance for this particular lesson is when B equals 0. So if B equals 0, then this whole middle term doesn't matter right now. So it's actually, what we're dealing with is f of x equals ax squared plus c. So some examples of what that might look like. F of x equals x squared minus 4. F of x equals negative 2x plus 7. F of x equals 3x squared plus 10. These are the kinds of equations we're going to be working with. These right here, right? So that's what ax squared plus c means, is that we've got a number in front of the x squared, could be positive, could be negative, and we've got a number after the x squared, could be positive, could be negative. And then it shifts and changes the graph in certain ways. Okay, so if you'll remember, or you don't even have to remember because I'm just going to show it to you again. This is the parent function, f of x equals x squared. F of x equals x squared. So this is the parent function. It sits on the origin and it opens upward. So it's got the vertex is a minimum, and it has it has one x-intercept. The vertex. The vertex is the only x-intercept, right? So that's the parent function, and this changes in certain ways. If I were to say x squared minus 2 that would move the graph down by 2 points. Come on, stop the glare. There we go. Does that make sense? If I were to say x squared plus 2, it would move the graph up 2 points. If I were to change it to negative x squared plus 2, it would reverse the graph and make it point down, but it would keep the vertex at that plus 2. The vertex stays at the plus 2, but now it opens down. That also gives it 2 x-intercepts, you see. Probably it's something like 1 and 1, 1 and negative 1, or 2 and negative 2, something like that. Let's see. What's next? Oh, the stretching. Yes. So I'm going to draw 3 graphs. That's not going to work. Do sideways. 3 coordinate planes. Here is the original graph. Right here, the original parabola is here. That's the parent function. F of x equals x squared. If I go 3x squared it's going to narrow the graph. Okay, it's going to shrink it in. It's going to shrink it in. If I go 1/3 x squared, it's going to spread it out. See that? The bigger the fraction, the more spread out it's going to get. The bigger the normal number, the narrower it will get. But it'll never touch the y-axis with this. It'll get close, but it'll never actually close and touch. It'll always have a little bit of space there. Those are just some basic concepts. The number after it moves it up and down, and then the number in front of it will shrink it or open it up.